Hey there, CS210 students. So in this recording, we're going to talk about the content for Chapter 1. I won't go through all the sections. I'm only going to go through the sections that I think are immediately pertinent to the work that you'll be doing. And then I'll also give you some details on how to do things for when you get to the assignments and then in projects and so forth. So as you can see, I'm in section 1.2. So we are writing C++ code. So one of the first things to note about C++ applications is that they do have a main method where it will look when it gets compiled to start running the code. So every program has a main method. So it's main and then open and close parentheses. And then C++ is a brace type language where blocks of code are enclosed in braces. Each statement in C++ ends with a semicolon. So how do you know if a programming part is a statement? Well, a statement tells the computer to actually do something. So if you are saving something to a variable, so for instance, you have a variable like wage and you're assigning it the value of 20, you're telling the computer, hey, save this value to this variable. So that would be terminated with a semicolon. But if you're just writing an if statement, so you're checking something, you're not telling the computer to do something. So an if statement or a while loop, things of that nature, those are not ended with semicolons. So keep in mind, if you're telling the computer to actually do something, you're not checking something, then it's going to be terminated with a semicolon. So that's a little bit of details there. So let's scroll down a little bit. So one thing, C++, and most of you are familiar with Python and Java. So in Python and Java, you have import statements. So in C++, you will be utilizing include statements or also using statements. So this is going to be including the IO stream. So this would be for file handling. Using namespace std here. This is the standard namespace. And so in there, you get things like cout and so forth. So let's scroll down a little bit here. And let's talk about getting input from the keyboard in C++. So to get input, we use the cin keyword, and then we use the extraction operator. That's this right here. That's the double angled brackets there, facing towards the cin, so opening towards the cin. So this is called the extraction operator. So what this does is this says, console, give me whatever you contain, and then this is going to save it to the variable called x. So again, we can kind of see an example down here. They've got a variable called wage that they've declared, and then they come down here and they say cin, assign whatever's in the console to the variable wage. So to get console input, this is what we'll be using. So cin, the extraction operator, and then you can assign it to a variable. Again, we're telling the computer to do something here. So get the input. So that's why this is terminated with a semicolon. So to display output to the console, we use the cout keyword with the insertion operators. That's what the double angled brackets are right here. So cout, and then whatever text we want to display. And if it's a string literal, that means it's the actual string that we have right here. Then you wrap it in quotations. So we can see right here, cout, and then we've got the string keep calm, and then we got cout and the word and then you got cout and carry on. So this is going to display to the console these strings. And as you can see in the output here, so this says keep calm and carry on. So all of this is on one line because we have not told the console that we want any new line characters. So to put a new line character, what you can do is you can use the end L keyword. So we would say cout and then insertion operator and then end L. In fact, you can do this all in one line. You could say cout, the string keep calm, and then the insertion operator again, and then end L. And that would display that as you see here. So if you have a variable, so the cout operation can display the values of a variable. So we have a variable called wage. It's been assigned the value of 20. So we see that they are printing out wages. That's the string literal. And then cout the contents of the variable wage. So that's going to grab its contents, which in this case is 20. So as they mentioned here, you don't put any quotes when you're accessing the variable's value. So you can, again, as I mentioned earlier, you can output multiple items with one statement. So here's an example where we're saying wage is, and then the wage, and then we're putting a new line character here. So keep in mind, this would be the preferred way to display your output. Don't put every single piece on a cout. Write what the line is going to look like one at a time. And then the last thing that I want to point out, two last things in this section. So if you need to read in multiple user inputs, what you can do is you can read those in using two cin statements. So you would say cin birth month, and then you would also then immediately grab the birth year as well. So when you get this hooked up and running, you will see how to implement that. And then that'd be a nice thing that you can utilize in your code, in your programs later on, is you can get all the input using one line. And then the last thing is that you can also place inside of a string a \n. So inside of a string \n, this would format it with a new line each time. So you would have 1, and then on the next line 2, and then on the next line 3, and so forth. In my opinion, I don't like it when you insert the new line character in a long string of text, like it gets lost in there, makes it hard to read. But maybe at the end of the string, if you want to use that instead of the end L, that would be fine. But they do notice that, do note that good practice is to use end L for your line endings. Okay, so section 1.3, let's talk quickly about comments and whitespace in your code. So a comment is text written by you to be read by the human and not getting compiled. So it's ignored by the compiler. It's not part of the compiled code, but it will be in there to give you hints or suggestions to let you know what things are doing and so forth. So in C++, we have a couple different ways to write comments. The first one here is the 2 forward slashes. So this is a single line comment. So everything after this double forward slash, everything after it is considered a comment. So it's not read in by the compiler. So we see an example of that here. So we've got number of people that will be eating. That's describing what this variable is right here. And then we also have a inline comment right here where we're saying get the number of people. So we're telling what we're doing here. We're going to get the number of people. A multi-line comment starts with the /* and ends with */. And so everything in between those two symbols are blocked out and considered a comment. So you can see here that they have a block comment where they're stating what this program is going to do, and then we get the author and date. So this would be a block style comment. Now, a couple things that I want you to understand with comments. I don't want you commenting every single line of code like you see here. Typically, what we should have in production code, so the code that you turn into me, is a comment. It's describing the variable's purpose, so that's okay. A potential comment explaining what an if statement's for or why you're looping for something. But a comment like this where you're saying get number of people, as I read the code, it should be self-documenting. I can already see right here, cout, you're printing out the output here. And then cin, you are getting the input from the console. So I don't need you to say, we're going to get the number of people. This could be right here removed. Also, we shouldn't have things like declaring variables as a comment. The code should speak for itself. If something is a tricky portion of codes, for instance, here they've got calculate and print total ounces of pasta. We probably don't need this comment right here because we can determine here that you're calculating something. It's doing arithmetic. And then again, we can see that you're printing the output. So what I want you to understand is a little bit is that less is more here. I don't need you writing every single line of code. And as we go through the assignments, if I see that, I'll mention it in the feedback to not do that. Also, one other comment about the commenting out actual code. Make sure that if you comment out code that you do not turn it in to me as part of a final grade, because we do not leave commented code out in production. We want to make sure that we have running code, and we don't want to leave something for somebody later on saying, why is this commented out? Why is it not being used, and so forth. Let's jump over to Visual Studio, and I do have one thing I want to show you in here. So I'm going to just start up a real quick little project. C++ console app, and I'm going to call this just module 1 demo and create. And again, I'm putting it in my Southern New Hampshire projects folder. And I'll just go ahead and copy this code right here, and I'm going to dump it into Visual Studio here. So I've already got a project started up. It's got a source file in there. So if this is what I started with, one thing, if you turned this in, I would ding you for leaving in these comments that are already provided. So any kind of boilerplate comments, things like type your code here, those are going to get dinged down the road. So the thing that I want to point out to you is you may find very useful is, let's say that you have a big chunk of code that you do want to comment out just for debugging purposes or testing purposes or whatnot. So inside Visual Studio, you'll see two buttons over here, one that says comment out the selected lines and one that says uncomment them. So if I select this, that will comment out all of these lines right here as a block. So very useful that I can come in here and uncomment or comment things out very quickly. Okay, let's jump to section 1.4 and let's talk a little bit about syntax errors and some type of errors you might run into. So in programming, syntax errors are when you don't follow the language's rules. So for instance, in C++, statements have to be terminated with a semicolon. Blocks of code have to have an opening curly and a closing curly. And if you do not follow the syntax of a language, then the IDE is going to give you a compiler warning. It's not going to compile, and it will not run. So for instance, if I go back to Visual Studio, and let's say that I get rid of this semicolon right here, I can see that I've got some red squigglies. Now, in C++, Visual Studio is not so smart sometimes. What it's doing is it's saying, all right, C in, okay, there must have been something wrong with the line above, and it's telling me it needed a semicolon. So there's my semicolon. If I get rid of this curly bracket, so again, it's going to probably say something like, I need an opening curly. Or if I get rid of this closing curly, so if I get rid of it, and again, this is where Visual Studio sometimes isn't the smartest. I'm not seeing any kind of warning, but if I run this thing, or if I just do build, build the solution, cross your fingers, I should get an error that this will not compile. And down here, here it is. So I get this error message that there's no matching token found. So I need to have the closing curly bracket there. If I don't have my insertion operators, I can see that I'm going to get a syntax error compiler warning here. So keep in mind, make sure that you're saving your code, you're running your code often, because you might get away a little bit where you have this missing, this that curly, and later on you're like, why is this not working? Where's the problem at? And you could have solved it by kind of running things as you make changes. One thing that a lot of people make comments about is that they don't like C++ or they don't like Java because they just don't like the programming language because they make lots of syntax errors. So that is one thing that you have to improve on. Don't use the excuse of the language with syntax errors, because it is completely on us as the developer to follow their rules. Even in a language like Python, if you don't have the right indentation, if you don't end your loops or your if statements with a colon, just like in C++ or Java, it's going to yell at you. So every programming language, if you don't follow the syntax, it's not going to like you. So make sure that you're getting in good habits, practicing those early on, getting things working and running. And then the last thing I'm going to talk about that they have in this section is that we have what they call logic errors. So logic errors are different than syntax errors because a syntax error is detected by the compiler. A logic error is a bug put in by you where something is not being done properly. So for instance, they've got a number of beans times number of jars, and they want to multiply, but they actually typed it as addition. So this program is going to compile, but it's not going to run as intended. So this is where you need to be able to test your code, where we want to make sure that we test, hey, did we get the right output for these inputs? And we'll talk later in our class how we can create some unit tests and make sure that things are running properly. Okay, so that's it for this recording. There will be a separate recording talking about the lab that you have to complete for this chapter.